This is SpaceTime Series 27, Episode 59, for broadcast on the 15th of May 2024. Coming up on SpaceTime, why Venus has almost no water, a space railroad on the Moon, and the launch of a new volcanic eruption early warning satellite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that Earth's scalding and uninhabitable sister planet Venus became incredibly dry after losing much of its atmospheric hydrogen into space through a process called dissociative recombination. The study claims that resulted in Venus losing roughly twice as much water every day compared to previous estimates. The new findings, reported in the journal Nature, are based on computer simulations, and they fill an important gap in science's understanding of the water story on Venus. One of the study's authors, Erin Kanji from the University of Colorado Boulder, says water is vital for life as we know it. Scientists need to understand the conditions that support liquid water in the universe, and that may have produced the very dry state of Venus today. Kanji says if you took all the water on Earth and spread it over the planet like jam on toast, you get a liquid layer roughly 3 kilometers thick. But she says if you did the same thing on Venus, where all the water's trapped in the air, you'd wind up with only 3 centimeters, barely enough to get your toes wet. You see, Venus has 100,000 times less water than the Earth, even though it's the Earth's nearest planetary neighbor. And that's really confusing because both worlds are basically the same size, they have the same mass, and they were formed in the same part of the solar system out of the same material. So why the huge difference? Well, Kanji and colleagues have used computer models to try and understand Venus as a gigantic chemistry laboratory, and they zoomed in on the diverse range of reactions that occur in the planet's swirling atmosphere. They found a specific molecule, an ion, made up of one atom each of hydrogen, carbon and oxygen, which is high in Venus's atmosphere, could be the culprit behind the planet's escaping water. Now, if they're right, these findings reveal new hints about why Venus probably once looked almost identical to Earth, but is now completely unrecognizable. See, if Venus is Earth's sister planet, then it's a twisted sister with a runaway greenhouse effect. Its surface is scorchingly hot, with average temperatures of 462 degrees Celsius. That's hot enough to melt lead. And those thick, opaque planet-shrouding clouds, well, they do cause rain, but the rain isn't water. Instead, it's droplets of metal-eating sulfuric acid. Scientists have seen what looks like snow caps in some of Venus's taller mountain ranges, but that snow isn't frozen water. It's actually metallic. Venus's thick cloud cover is so heavy, it crushes Venus's carbon dioxide-based atmosphere, acting like a lid on a pressure cooker, and giving the planet a surface pressure some 92 times greater than the average sea level surface pressure on Earth. The surface of Venus is dominated by thousands of volcanic structures, more than any other planet in the solar system. Importantly, there's no evidence of any form of plate tectonic activity on Venus. Venus orbits the Sun every 224.7 Earth days, and unlike the Earth, it rotates in retrograde compared to most other planets in the solar system. That means on Venus, the Sun rises in the west and sets in the east. And the rotation is awfully slow. A day on Venus lasts 243 Earth days. That means a Venusian day lasts longer than a Venusian year. Venus wasn't always such a dry, inhospitable world. Scientists suspect that billions of years ago, during the formation of Venus, the planet received just as much water as the Earth did. But at some point, catastrophe struck. Clouds of carbon dioxide in Venus's atmosphere kicked off the most powerful greenhouse effect in the solar system, eventually raising temperatures on the surface to roasting, and in the process, all of Venus's water evaporated into steam, and most of it wound up drifting away into space. But that ancient evaporation can't explain why Venus is as dry as it is today, or how it continues to lose water into space. Now, according to this new study, the culprit is this elusive carbon-hydrogen-oxygen ion. Water mixes with carbon dioxide to form this molecule. In previous research, the authors reported that the same molecule may be responsible for Mars losing a huge chunk of its water. Here's how it works on Venus. The molecules being produced constantly in the atmosphere, but the individual ions don't survive for long. Electrons in the atmosphere find these ions and recombine with them, splitting the ions in two. Now, in the process, the light hydrogen atom zips away and may even escape into space entirely, robbing Venus of one of the two components needed for water, H2O. The only way to explain Venus's dry state was if the planet hosted larger than expected volumes of this molecule in its atmosphere. Now, there's one more twist to the findings. Scientists have never actually observed this molecule around Venus. While many spacecraft have visited Mars in recent years, far fewer have travelled to Venus, and none have carried instruments capable of detecting this hydrogen-carbon-oxygen ion. One of the surprising conclusions of this new research is that the molecule should actually be really common, one of the most abundant ions in Venus's atmosphere. So, all they need to do now is go there and find it. This is SpaceTime. Still to come, NASA looking at building a railroad on the moon to transport freight across the lunar surface. And a new satellite's been launched from the International Space Station to study volcanic activity from orbit. All that and more still to come on SpaceTime. NASA's looking at building a railway on the moon to transport freight across the lunar surface. The magnetically powered robotic flexible levitation on track or float system would transport up to 100 tons of lunar soil or regolith and other materials a day using unpowered robots. The float would involve lightweight tracks being unfurled directly onto the lunar surface, thereby avoiding all the major on-site construction problems associated with traditional transport infrastructures like conventional roads, railways, or cableways. Ethan Shaler from NASA's Jet Propulsion Laboratory in Pasadena, California, says unlike robotic vehicles with wheels, legs, or tracks, float robots have no moving parts and levitate over the tracks, minimizing lunar dust, abrasion, or wear. Transporting regolith across the lunar surface would be vital to NASA's plans to convert the soil into oxygen and building materials to support human bases on the moon. Also, the extracted oxygen could be used as an oxidizer for rocket fuel. Float would operate autonomously with minimal site preparation, and its network of tracks could be rolled up and reconfigured to match evolving lunar-based mission requirements. JPL engineers estimate it will be capable of handling payloads of more than 30 kilograms per square metre at speeds of half a metre per second. Float is just one of the concepts being looked at by NASA for funding as part of the agency's Innovative Advanced Concepts Program Phase 2 projects. The others include a fluidic telescope or FLUTE, which would involve the creation of a large optical observatory in space, not using a solid heavy piece of glass as a mirror, but instead having a fluidic mirror shaped by rotating ionic fluids. The telescope would allow astronomers to search for Earth-like exoplanets, first-generation stars, and young galaxies. Then there's the proposal for pulsed plasma rockets. These would dramatically reduce transit times for humans travelling to Mars or other parts of the solar system. This innovative propulsion system would use fission-generated packets of plasma for thrust. Another idea is the Great Observatory for Long Wavelengths, or GLOW. It would see a mega constellation of low-frequency radio telescopes using thousands of autonomous smallsats capable of measuring the magnetic fields emitted by exoplanets and study the cosmic dark ages, a time before the first stars began to shine. Then there's the radioisotope thermo-radiative cell-powered generator. It would be a new in-space power source operating at higher efficiencies than current power generators. And finally, there's science craft for outer planet exploration. It would place quantum dot-based sensors on the surface of solar sails, enabling that cell to act like a giant innovative imager. Quantum physics would allow NASA to make scientific measurements through studying how the dots absorb light. By leveraging the solar cell's area, it would allow lighter, more cost-effective spacecraft carrying images across the solar system. This is SpaceTime. Still to come. A new volcanic eruption early warning satellite launched from the International Space Station, and later in the science report, artificial intelligentsia showing clear racist and woke programming. All that and more still to come on SpaceTime. A new satellite has been launched from the International Space Station to study volcanic activity on Earth from orbit. The Hyperspectral Thermal Imager, or HITAI spacecraft, is a 6-unit CubeSat designed to measure trace gases which could be an early indication of an impending volcanic eruption. The spacecraft was initially launched from Earth on the 30th SpaceX commercial resupply mission aboard a Dragon cargo ship on a Falcon 9 rocket from the Cape Canaveral Space Force Base in Florida back on March the 21st. After docking to the International Space Station, HITAI was deployed into low Earth orbit on April the 21st. This demonstration mission will test new technologies that could provide the next generation of high spatial, spectral, and temporal resolution satellites using thermal infrared imagery acquisition from low Earth orbit. HITAI principal investigator Robert Wright from the University of Hawaii says the mission will pave the way for future spacecraft dedicated to detecting volcanic eruptions weeks or even months in advance. Wright says hyperspectral images like HITAI can measure a broad spectrum of thermal radiation signatures, and they're especially useful for characterizing gases in low concentrations, quantifying concentrations of sulfur dioxide in the atmospheres around volcanoes. You see, in the weeks and even months before they erupt, volcanoes often emit increased amounts of sulfur dioxide and other trace gases. So, measuring those gases could indicate an impending eruption. HITAI's sensitivity to thermal radiation will also be useful for observing water vapor and convection. Wright says a future constellation of 25 to 30 HITAI satellites could monitor Earth's volcanoes for signs of impending eruptions and map soil moisture for crop management at lower costs than a single conventional satellite.
I tell people that I study volcanoes from space to try and work out when they are going to start and stop erupting. The satellite is called HITAI, Hyperspectral Thermal Imager. There are two science objectives for HITAI. One is we want to try and improve how well we can predict when a volcano is going to erupt, and also when a volcanic eruption is going to end. And we're also going to be measuring soil moisture content as it pertains to the persistence of drought. So both of those things HITAI will be able to contribute to society. HITAI uses a phenomenon called interference. If you've ever seen the rainbow of colors that are produced on the side of the street when you have a film of oil over water, that's an interference phenomenon which allows broadband light to be split into its different color or wavelength or spectral components. HITAI uses a Fabry-Perot interferometer, which is about the size of my fingernail, 2 pieces of germanium, and we just have air in the middle. When light lands on one side, it gets passed through and it gets bounced around in the cavity, reflected backwards and forwards. And it's very attractive as an imaging technology for a cube satellite, firstly because it's small, but secondly because it has no moving parts. It's just glued together solid and mounted to the focal plane of it. People are familiar with carbon dioxide exolving from a liquid when you open a bottle of Coke. Carbon dioxide is also present in magmas at depth. When you're bringing the magma up to the surface, the gases which are dissolved under pressure at depth, eventually they escape and they produce a gas cloud. Before an eruption, carbon dioxide can give you weeks to months of early warning once you start detecting that elevated amount within that plume. With HITAI, we have the sensitivity, the spectral coverage, and the spectral resolution that we can measure both volcanic carbon dioxide emissions as well as volcanic sulfur dioxide emissions. Our ability to measure the chemical composition of targets on the Earth and how they change as a function of time in the thermal infrared has really lagged behind progress that has been made in other parts of the spectrum. Everything emits energy because it's warm. In the thermal infrared, we're studying the amount of light that it emits. We make many spectral measurements with narrow wave bands, which is what HITAI is going to do. Then not only can we work out the temperature of the thing we're imaging, we can also work out something about its chemical composition. So HITAI is going to provide a different kind of thermal infrared data than scientists have previously had available to them. One of the most frustrating things about being a scientist is that you're usually given data and you have to work with it, even if it's not exactly the kind of data that you really like to bring to bear on the problem that you're trying to solve. Historically, the conversion from a meaningless number to a scientifically meaningful number would take place on the ground. With high tide, we're going to do this processing on board. So what we have to do is convert the raw response of the camera to the thing called spectral radiance. During a given day, the instrument's going to acquire about 100 gigabits of raw data. And by processing it on board and then compressing it, we're going to convert 100 gigabits to 4 gigabits, which on download, a scientist could grab, unzip, and then immediately begin analyzing. A high-tide CubeSat. CubeSats are designed to work in constellations, so to replicate the functionality of a large mission using several smaller spacecraft. High-tide is a technology demonstration mission, so it's not designed to be a science mission, it's designed to be a pathfinder for a science mission. So in order to achieve high temporal resolutions of the kind that you need to study the gases emanating from a volcano before it erupts, then one high tide would not do that, but a constellation of 8, 9, or 10 high tides would. So we work at the University of Hawaii and we're doing this, but there are some things it's just better to rely on NASA to handle. The ESTO program allows for scientists to have interesting ideas and actually turn them into reality in a timescale which is not measured in decades, but is measured in months to years.
That's Robert Wright, the director of the Hawaii Institute of Geophysics and Planetology at the University of Hawaii. And this is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that ultra-processed junk foods, especially processed meats and seafoods, are associated with a higher risk of dying prematurely. The findings are reported in the British Medical Journal, are based on research following the diets of 100,000 American healthcare workers over an average of 34 years, half of whom died during the study period. The authors say there was no association between eating more ultra-processed foods and deaths related to cancer or heart problems, and so the overall increased risk of death could be explained by the overall diet quality. In an accompanying editorial, the authors note that it's important not to regard all foods considered ultra-processed as unhealthy in all contexts, and also not to equate under-processed foods as being especially healthy. Scientists have found that harnessing the same chemical processes that capture carbon dioxide from the atmosphere could also allow for the carbon-negative production of concrete. The findings, reported in the Journal of the Royal Society Open Science, follow experiments using olivine, a mineral commonly found in Earth's upper mantle. The mineral was broken down into an amorphous silica, which has the potential to be used as a supplementary material in concrete making, and nesquehonite, which is able to capture and store carbon. The authors say using silica for cement would give concrete a low, potentially negative carbon footprint, as a carbon-capturing material is being created during its production. Right now, concrete is considered to be the worst construction material for greenhouse gases. Artificial intelligence, or AI, is the fastest-growing technology in the world, but there's growing concern about its ability to consider and represent diverse communities. Prominent AI applications such as Google and Meta are showing racial biases, a lack of diversity, and a lack of cultural sensitivity. For example, Google's AI has been shown to be culturally woke to the point where it ignores achievements of white people, such as claiming George Washington was black and the Apollo 11 astronauts were all coloured. AI expert Professor Kevin Wong from Murdoch University School of Information Technology says in order to deal with the problem of cultural biases in AIs, it's important to understand the fundamentals of different AI techniques. It's also important to remember the racist biases of the programmers scripting the AI, a clear case of garbage in, garbage out. Apple has formally released its new Apple Air and Apple Pro iPads, and as expected, the Pro includes the new top-of-the-line M4 chip. With all the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, 2 iPad Airs, an 11-inch and a 13-inch, and 2 iPad Pros, an 11-inch and also a 13-inch. Now, that's bigger than the 12.9 inches they had last year. And the iPad Pro 11-inch is 5.3 millimeters, and the 13-inch is 5.1 millimeters. Now, that is smaller than the iPod Nano from a few years ago, which was 5.4 millimeters. So it's incredibly thin. And already people have made jokes that, well, it's just going to bend. This is Apple's first foldable, but clearly most people are going to have this in some sort of a case, And you've got to be careful because it's going to be a very
I remember
expensive.
That happened with iPhones a while ago. I think it was the 6,
Well,
wasn't it?
it was the 6, and also the 2018 iPads could bend as well. But again, if you sat on it, if you purposefully bent it, the reality is most people will have them in cases. And the price of these things, especially if you want the 2 terabyte version, is going to be in Australian dollars $4,000 to $5,000. I mean, these are not cheap devices. But the iPad Air is the one that's meant to be more for everyday consumer, especially the one that wants the larger 13-inch screen without having to pay the Pro prices.
Of course, the big question is, did the M4 chip come out, and if so, with what?
Yes. So the iPad Air has gone from M1 to M2, and that's a big improvement for the consumer range. But the Pro range has skipped the M3 entirely and gone to the M4. Now, that's why Apple didn't launch it earlier, because they were clearly waiting for this chip to be launched. And it's 50% faster than the M2. I mean, they didn't say how much faster it is than the M3, but given there's no M3 iPad Pro, it doesn't really matter. It's a faster and better device. And it's got the biggest, sort of most powerful neural engine, which delivers AI. Now, Apple has studiously avoided mentioning AI. They've always talked about machine learning, but this time they said it 7 or 8 times. And they gave some examples where you could take some sort of a dancer and just tap on this particular dancer and move it into a different video editing timeline without all the background. And you could just do that with a tap and a drag. There's another example with a song with Apple's latest music software version 2, where you could just tap a button and instantly the song is broken up into the singer and the drums and the main instrument and the backing instruments, and it all happens in a blink of an eye.
Oh, wow.
And you can then remix things. What Apple didn't show, and what they were saving for their big worldwide developer conference in early June, just weeks away, is whether or not Apple is going to have a large language model generative AI clone or competitor to ChatGPT, which would be like a Siri on steroids. And so there's clearly another shoe to drop in terms of what Apple's true AI response to ChatGPT is going to be and how else that will be used throughout the system. I mean, already Samsung devices can do live translation on device whilst you're on phone call from one language to another. It can automatically convert audio files as it's being recorded into text, summarize that for you, change the tone of your emails and notes from something more casual to something more professional. I mean, there's a bunch of things that Samsung showcase, which iPhones can do, but you need different apps for that. But it's built directly into the operating system. And so this is something we expect to see Apple launch. And the big question will be whether or not you need an M4 powered iPad Pro or a forthcoming MacBook, which will be launching towards the end of the year, with these chips to do all that on device, and also the new iPhone 16 that will come towards the end of the year, or whether or not you'll be able to do a number of these things on your existing MacBook Pro devices, and then how far back. Can I use these AI features that aren't official yet on my iPhone 15 Pro Max, for example? Can I do it on an iPhone 15? Can I do it on an iPhone 14 or 13? Now, where will the cutoff be? Because Microsoft is going to launch its Surface device in the next week or two. We'll talk about it on this show. And it will have the Snapdragon Qualcomm X Elite and the X Plus. And these two chips are their answer to Apple's M series chips. And they've come effectively 5 years after the M1 was released in 2020. Now, one interesting point, Qualcomm said its chip can do 45 tops. That's trillion operations per second. And Apple only said it can do 38 tops. Trillion operations per second. And this is important because Microsoft has been reported to say that to do generative AI on device, you need at least 40 tops. And interestingly, AMD's chip does 39, and the previous one last year did 33. So is Qualcomm's better at 45 than Apple's at 38?
And of course, it doesn't end there. There's more news from Google as well.
Yes, as we're going to air, Google will be holding its I/O Developer Conference, which will be full of AI news and information, and it's also going to officially launch the Google Pixel 8a. It'll go on sale when the conference is on, and that's full of AI stuff too, Circle to Search and Google's AI built into the phone, and it's at a price in the US of $499, $849 in Australia, $100 more, but it's their answer to the mid-range phones that are nearly high-end and have all of the pure Google goodness and 7 years of OS and security updates. So Google is by no means wanting to be left behind either, and they have plenty of news, which we'll talk about next week.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.